today, where we'll be covering everything like previous question papers for class test 3. So today it's not online session, it's online consultation for the students who booked one. So yeah, so I wish maybe someone can just reply to that message, that one in the group, because I think I did specify yesterday that today it's online consultation via MS Teams, and I did also send a link, a booking link in the group. Maybe other students, they did not see the link. So please let me know if you can hear my voice, because I'm going to record the session and I'm going to post it there on my YouTube channel. Yeah. Okay, let me just do this before I record. Right. Let's... Okay. Okay. All right. Oh, there's someone who recorded the session. Okay. I hope you're all aware that you're writing the class test 3 on Thursday. Yeah, let me just check here. On Thursday, the 9th of April. It will be based on chapter 5 and chapter 6. So for all the students who booked for online consultations, before we start, I just want to hear from you. Do you all understand chapter 5? If you all understand chapter 5, maybe you can react by using the one of those emojis there, or you can unmute your mic and speak. Do you all understand chapter 5? Okay, that's great. I see. What about chapter 6? Okay, I only see one reaction there for chapter 6. So meaning you're all okay with, you can, okay, I see someone saying no. Okay, it's fine. For those who don't understand chapter 6, please send the messages in on the chat, on the chat, because I see there are 2 no's. No. Yeah, please send the message so I can see how many students want us to do chapter. Who wants us to do chapter 6? Okay. Okay. I don't understand chapter 6. Okay, no. Chapter 5 and 6, no. Chapter 5 and 6, no. Okay, fine. Okay, so okay, I can see that there are, let me check it, how many students? 1, 2, 2. I see two. So I see there are 2 students who are saying they don't understand chapter 5. No, it's 3 now. 3. So okay, this is what I'm going to do now. We're going to start with chapter 6, because I feel like chapter 6 is the easiest. I'm not saying that chapter 5 is difficult, but we are going to start with chapter 6. Then after chapter 6, we will do a revision of chapter 5, because chapter 5 it's very short and easy. So but I want us to start with chapter 6 before we do the questions that are based on chapter 6. We'll also do a revision of chapter 5. So I don't know if you guys are okay with that. Okay, can you please do both? All right. So for those who are saying, can you please do both? How about we start with chapter 6, ne? We start with chapter 6, and after chapter 6, and then we also do a revision of chapter 5. So then after chapter 5, we can do 2025 question paper, just few questions, because obviously tomorrow on that online session, I think it's going to be I think 2 hour, I'll see 1 hour 30 or 2 hour session. That one, the one tomorrow. So on that one, we'll be doing question papers. So yeah, so I think since the one here tomorrow will be doing the question papers, the one here today, the one with the online consultation, we can do chapter 6 we start from scratch with the chapter 6. Then after, we do a revision of chapter 5. Yeah. All right, great. Okay, I'm going to share my screen. I'm just going to open something now here. Is it? What's this one? I'm just going to share my screen, and please let me know if you guys can be able to see my screen on your side. I'm just going to share my screen now. Just this. So just make sure that with chapter 6, you just get full marks, because that chapter is very easy. Yeah, please let me know if you can all see my screen on your side. Ne? If you can all see my screen. Right, let's gonna start from here. I hope you can all see my screen. Ne? Okay, it's fine. Just gonna do this. This one is fine. All right, I see someone is typing. So, but I believe you can all see my screen. So yeah, let's start with chapter 6. All right, now with chapter 6, we're going to talk about the simple regression and the correlation analysis, the easiest chapter. So now with the simple regression and the correlation analysis, most of the things with regards to my calculations, we will be using a calculator, a casual calculator. So I will advise you all to make sure that now you have your calculator in front of you. Maybe you have a pen. You also have a book where you're going to take some notes. You also have a calculator, because we will be using a calculator to calculate what we call the correlation coefficient, which is R, the coefficient of determination, the least square regression equation, the residuals, and so on. So make sure that we have those things that I mentioned. So now, we'll start with this one. Okay, no, let me just erase this one. So now this is the learning outcomes. So now when you look at the learning outcomes here for this simple regression, so we're going to start with the one for the scatter plot. I mean the scatter plot, because the introduction you will see like with the introduction. After the scatter plot, remember you won't be required to draw any graph, because it's multiple choice. So meaning you will be given a scatter plot, then you are going to do what we call, you're going to interpret the scatter plot, whether to check if it's positively skewed, it's negatively skewed, or strong, weaker, and so on. Please bear in mind that you won't be required to draw any graph. And now with 6.3, the Pearson correlation coefficient, you are talking about R, with this one, R. So now we're going to use a calculator, a casual calculator, to get this one, to get this one, and to get this one. So meaning 6.3, 6.5, 6.6, I believe with regards to the test or the quiz, you must get full marks with regards to this. Same applies to the one with the scatter plot. So now let's see. Was just the introduction? Yeah, just giving us the thing, the X and the Y. But before we move to the scatter plot, remember guys, when you guys were doing chapter 3, I think you were doing chapter 3. When you were doing chapter 3, I think it was chapter 4, you were dealing with what we call the data. You're dealing with ungrouped data, group discrete data. So you were not dealing with the two variables. It was only, you're dealing with only one variables. So now with chapter 6, now we are dealing with the two variables. We are dealing with the variable X and the variable Y. So that's why now, when you measure the relationship between the X and Y, because you are dealing with the two variables. So this is very important. It's very important to make sure that, since you know that you are dealing with two variables, X and Y, the variable X, it's when you are talking about independent variables. So make sure that you note that on your notes, that Under chapter 6, the simple regression and the correlation analysis, we are dealing with the two variables, x and y. Where x, we are talking about the independent variable, does not depend on any other variable, x. And then the y variable, we are talking about the dependent variable. So the y variable obviously will depend on the x variable. So for example, when you look at the number of study hours as the x and the test mark as the y, so obviously you can see that the test mark will depend on the number of study hours. So what? So now the test mark will be the y. The reason why I'm showing you guys this and explaining this is because in the test or in the exam, you will be given a table, and on that table, they won't tell you that this is X, this is Y. Yes, some questions, yes, you will be given a table, and then they're going to specify this is X, this is Y. But with when you check other previous question papers, that's when you see that no, on this one, they just wrote number of study hours, and then on the other column, they just wrote test mark. How will I know that this one is X and this one is Y? So that's when you'll be like, okay, between the number of study hours and the test mark, between those two, which one will depend on another variable? So which now, when you check, you will be like, oh, it means that the test mark will depend on the number of study hours. So the test mark will be Y, and then the number of study hours will be X. So that's how you determine the two variables, whether to see whether this one is X and this one is Y or one. Yeah. Oh, wait. Yes, sir. Okay, let me just reply to this message in the group. Mm. All right. Okay. Okay, let me I just want to send this link just to this. All right. Now, any questions with regards to the independent variable and the dependent variable? Any questions before we move to the scatter plot? Any questions? All right. For those who just joined now, we're talking about the independent variable and the dependent variable. That with the independent variable, we're talking about the x variable, and then the dependent variable, we are talking about the y variable. So yeah. So now we're going to move to the next section. We'll be talking about the scatter plot. Okay. But now, before we move to the scatter plot, I want us to talk about this. I'm just going to erase here so that we can look at this whole thing here on how to interpret this, because I think most of the questions will be on chapter 6, because remember, with regards to the previous class test that you wrote, it was based on chapter 4 and 5. So obviously, even now, chapter 5 is included, but most of the questions, I think, will be based on chapter 6. I think will be based on chapter 6. So most of the questions. So right, now let's talk about this now. So this whole thing here, we call this contingency table. Right? Some they say it's a bivariate data. So they call this bivariate data. So how do we interpret this? Because you will be given this in the test or even in the exam. Can someone please admit students who just joined now? Please admit them in the lobby. Please admit for those who just joined. I think I'm okay. Okay. So, okay, I was saying that, yeah, someone will just admit those who want to join. Please admit them. So, okay, I was saying that now with regards to this table, we call this table a contingency table. Ne? This table is easy, ne? But the tricky part about this whole thing, but it's not that difficult. Ne? This is how you interpret the table. Now, you will be given a table like this one, and you know that to get the total here under this column of 0, you're going to say 16 plus 6, you get 22. Same applies to this one, 1 plus 1, you get 2. And then 2 plus, this one, 1 plus 5 is 6. You get the total for the column 0, column 1, and column 2. Now, to get the total for the row of 0, the gender under 0, you're just going to add 16 plus 1 plus 1, you get 18. Then the 1 for 1, 6 plus 1 plus 5, you get 12. Now, the reason why I'm saying this, or the reason why I'm explaining this table is because you will be given, they will say for each, you see where there's 6 here. Let me put the 6. They're going to put the value of A, and then they will tell you, which you must find the unknown variable, that's A, or the unknown value A. And how do you get A? Anyone? We know that it's equal to 6, but how do we get 6? Because I just cancel that part.
Say, I think you'll add your column 1 and column 2 to get your column 0.
Okay. But then, okay, to get the value of A, which method are you going to use? Because you can use 2 methods.
So I think you just say 22 minus 16 and you get the value of A, which is
yes, that's correct. And then another method, because you can also use the other one of 12 to get 6. It's either you can say 22 minus 16, you get 6, or you can use this one here, 12. So obviously, when you use this one of 12, you're going to say 5, you're going to say A plus 1 plus 5 is equal to 12. Therefore, 1 plus 1 plus 5 is equal to 1. Then you say A plus 1 plus 5, that's 6. So A plus 6 is equal to 12. Therefore, you solve for A, and then A will be equal to 6, because 12 minus 6 is equal to 6. So you can solve this in 2 ways. It's either you can solve it by using the column of 22 minus 16, you get A, or you use this method of the row, where you say 12 minus 6, and then you also get 6. Yeah, so any questions before we move to the part of the relative frequency? All right, great. Okay, guys, there are students who just sent me a message saying that they did not get the link. The problem is when you book using the website that I created, the minute you click OK, it must show the details. Like it must direct you to a WhatsApp where I will get the notification. Meaning on my side, I will get the notification via WhatsApp, and I'll also get the notification via the email. So the student who just texted me is because I did not get the notification via the WhatsApp. So I think, yeah, the problem was that. But next time, I think we'll fix that. So yeah. So any questions before we move to the part of the relative frequency? Okay. All right. Now let's move to the part of relative frequency. So I hope you all know how to calculate a relative frequency from chapter, I think it was chapter 3. Yeah. You all know that a relative frequency is equal to what? Let me just show you something. Is equal to the frequency divided by n. We all know this formula. So now, go chapter 6. You will be given this table. It's either they want you to find the unknown value of A, B, C, any letter, and which I just showed you on how to do that. It's either you're going to find that, or you will be given this table and they will tell you that you must calculate the relative frequency. And how do you get, when they say calculate the relative frequency, how do you get the frequency and how do you get the n? Remember here, we are given the totals. We are given the total of 18, 12, 30, 22, 2, and 6. So, okay, let's talk about this. Let's just interpret the whole thing. Ne? Let's say, for example, they want us to calculate the relative frequency. Okay, let's say the 0 is for female. Okay, I want to show you something. And then the male, it's 1. Ne? Okay, and then here where the value of A, we know that it's equal to 6. Let's say now, they say calculate the relative frequency of a male. Look at this. Like when you check the question, they say you must calculate the relative frequency. Where they're not telling you that the person under the smoke of 0, 1, or 2, they don't specify. They just say calculate the relative frequency, male. The relative. And you know that you need the frequency, you also need N. So which formula are you going to use? Obviously, you're going to use the one with R. R is equal to the frequency divided by N. And what will be the value of the frequency? What will be your frequency? Now, remember, since they said for the male, you're going to use 12. Why are we using 12? Because they don't specify whether the person under the smoke Y, it's 0 or 1 or 2. So we use the total for your male. So that's why you're going to use 12. We use 12 divided by what? By N. And N, we are talking about the random sample, which is 30, like this. You get this. That will be 12 divided by 30. And then you get the total. I mean, you get the answer. That answer will be the relative frequency. But if they say, what is the percentage or the relative frequency percentage, then you're going to say 12 divided by 30, then you multiply it by 100 to get the percentage of one. So that's how you calculate the relative frequency. So yeah, please let me know if you have any questions. Okay. So I believe you all understand me. Okay, great. All right. So now let's say again, they say you must calculate the relative frequency of a female under the column of 1 here, under this column. So are you still going to take 18 as your frequency, or are you going to take 1? Let's now interpret the whole scenario. Let's say now they say you must calculate the relative frequency of the gender of female, but under the smoke Y of the column 1. So I'm saying, what I'm asking you guys is that, are you going to take, on the previous question, we said we are going to take 12 because they did not specify whether under the smoke we must use the column of 0, 1, or 2. So now they say calculate the relative frequency of the 1-year female, and then now you under the column of 1. So are you going to take 18 as your frequency, or you're going to use 1?
Going to use 1.
Okay, yeah, correct. Then why are we using 1?
Because we're instructed that it should be under column 1, not under the total of.
Yes, that's correct. So I hope also other students, they also understand. Or do you guys have any other, do you have any questions?
No.
Okay, great. So meaning you're all fine with the how to interpret the contingency table, ne? I hope you're all fine. Okay, great. Okay. So if you're all fine, we'll talk about the scatter plot. But before we talk about the scatter plot, okay, let's do this. To make sure that you are all fine, this one. So I'm just gonna do this. Okay, I'm just gonna do this, erase this whole thing here. All right, I'm just gonna put this. Okay, so this is the table, ne? Remember I said the table is contingency table. This is the table that will be given. before you can even look at the questions, who can tell me what is the value of X here? I think we said you can use two methods. You can use the one column, you can use the one row.
30.
30.
Okay, how did you guys get?
30.
Is it
70 minus 40.
and then you can also say
We're gonna
50.
say X plus 20 equal to 50, then transpose of 20.
Yeah, then X will be equal to 30. So now here, how many students they want you to calculate the value of X? So you can see that is 30. So I want you guys to get all these 2 marks. It's 2 marks. Okay, what's the other thing? Then now look at this. Calculate the relative frequency of students who failed the test. It's very important to make sure that you analyze the question. You see, when you're dealing with stats, you must always make sure that you must ask yourself questions. You can't just say, no, the question is saying I must calculate the relative frequency of students who passed the test. I'm like, nah, I'm just going to check and take 70 and what. You need to check this set of students who failed the test. The question is who failed? Under which row? I want to know. Under the one for less than 5 hours, at least 5 hours. They don't specify that. So you're going to look at the column of those who failed. Okay, let me just do this. You're going to look at the column for the ones who failed, the ones who failed the test. So we are going to take 30 as the frequency. 30 will be the frequency. And then now the total number of the test result or of the students, both those who failed and those who passed, it's 100. So we are going to say 30 as your relative frequency. You just want to say that for R is equal to 30 as your frequency, then divide by 100. And then you will get 0.3.
0.3.
Yes. So any questions?
No.
Any questions before we move to the other question? Do you guys have any questions before we move to the next one? Okay, that's great. Okay, let's look at the other, what's the thing? Question 3. Yeah, after question 3, then we'll discuss the scatter plot. Okay, sorry about that. Let's look at question 3. Question 3, it says what percentage of students, who studied 5 or more hours passed the test? So with this kind of questions, remember, I think it's this one here. This one here, the one where we said with the percentage, you do this. You say, you use the formula of the relative frequency, you multiply it by 100 to get the percentage. Now look at this one here. So they say, what percentage of students who studied 5? So we have 2 keywords here. 2 keywords. So keyword number 1 is those who studied 5 or more hours. But now they did what? Those who passed the test. So now if it's like this, since we have 2 keywords, so we're going to check under those who did what? Let me cancel this one. So they said, which one? Who studied 5 or more hours? So obviously 5 or more hours, it's under this row. And then you're going to check under which one? They said those who passed the test, which you're going to take 40 here. All right, now look at this. Now here's the question. Now, since now we know, now the question is specific. We were told now for those who studied at least 5 hours and then they passed the test. So the question is, what will be the value of N? Are you going to take 70? Are you going to take 50? are you going to take 100? Because both it's either we can use 70, we can use 50, we can use 100. That's why now I'm saying that now you have to think out of the box when it comes to this kind of questions. So, okay, let's talk. Which one are you going to use? Are you going to use either 70, 50, or 100?
I think it's 50.
Right? Someone was saying, are we going to use?
Oh, 70, I think.
I think we're gonna use 70.
Okay, let's do this. So we are saying that you're going to say 40 divide by 70 and then multiply by 100. Okay, now that's number one. Then I had someone saying 50, ne? I had someone saying 50. So I had someone saying 50. So 40 divide by 50 and then multiply by 100. Okay, that's number two. Like this. All right. And then, okay, now, anyone who, I thought someone would just say we are going to use 100.
Yes.
Okay, that's okay. 40 divide by 100 multiply by 100. So that's 40%. Okay, to get the percentage. Okay, now we have three things here. Now, which one are we going to use? It's either 1, 2, 3. So I had someone saying you're going to use the 70, the other one 50, the other one 100. Okay, let's look at the question. What percentage of students who studied 5 or more hours passed the test? So we only look at the row where study hours are at least 5. So we all agree that 40 is there. We are going to use 40 as our frequency. We all agree, ne? Okay. The only problem here is the value of n. Okay, it's fine. So from the row of at least 5 hours, we're going to take the number of students who passed the test at least 5 hours, which is 40. And under that row of at least 5 hours, we also have the number of students who failed the test, which is 10. Again, which is 10. So now, remember the whole thing, 40 and 10, they both fall under the row of at least 5 hours, which now, when you add the 40 and the 50, you get the total number of students who studied at least 5 hours, which will be 50. Now here, this is what you're going to do. Since now the question is really specific, we're going to now go and check under at least 5 hours and check the students who passed the test, which is 40. So now the relative frequency will be, the relative frequency is equal to the number of students who passed Kamara the row of at least 5 hours, which will be 40. Divide by the total in this group, in this group of at least 5 hours. So that will be 40 divided by the total number, that row of 5 hours, which will be 50. So meaning now the method that you're going to use this one here. You're going to use the one with 40 divided by 50 multiplied by 100, which you will get 80%. I think so, which you will get 80%. This one. That's why I'm saying that this kind of questions, did tricky, but you have to, like, okay, if you say applies with theory questions, you have to ask yourself questions. Okay, I have three things. 40% was there. I think so. 40% was there. Yeah. I'm not sure about the one where you say 40 divided by 70, you'll get the answer. That one, I don't think it's there. If you say 40 divided by 70 multiplied by 100, what do you get there on your calculator?
57.
57. So this one over that is not there. It's not. So obviously you will be left with two things. You'll be like, okay, it's either now the 40 divided by 70 is not there. So am I going to take 40 divided by 50 or 40 divided by 100? But you need to understand, why are we using 40 and why are we dividing by 50? And if you say we're going to divide by 100, why are you dividing by 100? Well, because now the minute you divide by 100, it means even the students who studied less than 5 hours, they're also included. They're also included. But now, because the question is saying, look at the question here. Students who studied 5 or more hours. So now, I mean, they are referring you to the column, or not the column, the row of at least 5 hours, which is 40. But the fact about referring to the row of 5 hours, and they want the percentage of students who studied 5 or more hours past the test. It means now you're going to take that 40, you divide your 40 with the 50,
50.
then you multiply by 100, then you get your 2 marks. Where is it? This one. So 2, 4, 6. So far you get 6 marks. So yeah, any questions before we interpret the scatter plot?
So why did we use the 50? Because the question says students who passed. 50 is the total of students are failing and passing.
Okay, okay, let's go back to the question. Okay, the reason why we used 50 is because they say, let's look at the question again. They say how many students who studied, no, not this one, no, I don't know that one of less than. They say they said what percentage of students who studied 5 or more hours and they passed the test. So now when they say who studied 5 or more hours, we know that that statement 5 or more hours, it means that it's at least 5 hours. So we are going to check under this row. Under this row. So when you check under this row, we also have a total, remember, under this row, which is 50. But now they said those who passed. I wonder if they said 1% of students, maybe they don't mention passed the test. They just say they want the percent of students who studied. Yeah. If they say what percent of students who studied at least 5 hours, then you are going to take 50 because our specify whether that those students they passed or they failed the test. So we're going to take 50, you divide by 50 with 100. But the fact by those who studied 5 or more hours and they passed the test. So when you check under the 5 hours rule, we're going to take 40 because they passed the test here. We're going to take 40. But now check, since you're going to take 40, remember you were referred to that row of 5 hours, which is this one. Then this is the total one. So meaning you are going to take your frequency of those who passed under that row of 5 hours, that's 40. You divide your 40 with the 50 because remember we are still under the 5 hours row. That's 50. The total number of them is 50 because we referred under the 5 hours. We divide it by, 40 divided by that 50, then you multiply it by 100. Then you get your percentage. I hope maybe it makes sense now.
It makes sense.
Right, great. So yeah, please guys, be careful of those kind of questions. I think you will get them in the test. So yeah, just make sure that you interpret those questions. Yeah. Okay, I want us now to check the one for the scatter plot, where we interpret the scatter plot. Okay. So okay, now with the scatter plot, we have 2 graphs now. So remember, please don't forget this now. You can also note it down. We use the correlation coefficient to measure the relationship between X and Y, where X is independent variable and Y is dependent variable. We use the R. And how do you get the R? On a calculator. I'm going to show you that method on how to get the R. So it's either we can use the R to measure the relationship, or we look at the scatter plot that you will be provided, or the one that you will be given. Now, when, let's say, for example, you're given this scatter plot here. You are given this scatter plot. And even though it's this one here. Now, the reason why they say that it's this scatter plot is a strong positive linear relationship is because when you look at the straight line inside those dots here, it's going up, it's increasing. Even the dots, they are like close to each other, but in a way, it's increasing. And when it's increasing, then it means that we have a strong positive linear relationship between the X and Y. But now, when you look at the dots, or when you look at the line, because sometimes they can just give you only the dots, but look at the trend, yellow dots, so on this one, the dots, the way the trend is decreasing. So when it's decreasing, it means that there is a strong negative linear relationship between the X and Y. So that's how you differentiate between the strong positive linear relationship and the strong negative linear relationship. That's number 1 and number 2. So any questions? All right. Okay. The number 3. Now look at the dots. Look at the dots on number 1 and the dots on number 3. Yeah, the dots now, they're still increasing, but now they are not close to each other. Some, they are far away from each other, but they are still under the trend of increasing part. So really, so under the increasing part, we say that we are dealing with a weaker positive linear relationship between the X and Y. Under this one, now it's decreasing, but the dots, they are far away from each other. So it means that we are dealing with, it's like this. When the dots in a trend, it's increasing. It means you are dealing with a strong positive linear relationship under the condition that if those dots are close to each other, we are dealing with a strong positive linear relationship. But now, when you look at the scatter plot, you see that the dots now, they are decreasing and they are far away from each other. It means you are dealing with a weaker negative linear relationship between the X and Y. That's number 1, 2, 3, and 4. That's how you interpret the scatter plot. So yeah. So any questions? Okay. Well, now let's get this one. So with this one, you can see it's like this. So there's no linear relationship here. We only look at even the dots. You can't even check whether they're increasing or decreasing. So there's no linear relationship. So now you saw 1, 2, 3, 4, and the last one on number 5. 1. So yeah, just let me know if you guys have questions now. All right, now this one. Now under the Pearson correlation coefficient R, let's look at this. So now we know how to interpret this, this one, and this one. So now with the R, okay, with the R, when you look at, you see that we have like this formula in it, Sx, Sy. Okay, now, please guys, if now, I'm not saying that you should not use the formula, né? Because there are other students who prefer to use the formula, the manual way, where you substitute the values and so on. If you are given a table, the one with X and Y, if you are given a table and you are required to calculate the correlation coefficient, please use the calculator. Don't use this one of SXY divided by standard deviation of X multiplied by the standard deviation of Y, because you'll end up making mistakes when you substitute those values on those formulas. So then you end up getting the wrong answer. I'll repeat. If you are given a table, the one here X and Y, please use the method on the calculator. Don't use this formula, because this one you end up getting the wrong answers. That's method number 1. Method number 2, if you are not given the table, you will be given AMA summation, something like this. You will be given this. And when you are given this, the only thing you do, go to the formula sheet and check this formulas. Check these formulas and substitute those summations on the formula. You get this one, you put it there. And then you also substitute the summation that you are given. You get this one, you put it there. You can also get this one, you put it here. Then you get this. And another thing, you know what they will do, ne? You might not be given the table. They give you the summations. And then you'll be like, here I'm given the summations. And maybe they will ask me to calculate the R. And then they say, calculate the covariance. And you'll be like, hey, what is the covariance now? They're talking about this. The SXY here. This is the covariance. Which formula are you going to use? This is the formula that you're going to use to calculate the covariance. And if they say calculate the standard deviation of X, use this formula. Sx stands for standard deviation of X. Sy stands for standard deviation of Y. Then to get that. Okay, but if you are given a table, then use the method on a calculator. So I'm going to show you guys how to calculate the correlation coefficient on a calculator. So, but before that, let's look at the properties. So even the properties, they are also important. So now you know how to interpret the scatter plot. So always remember your correlation coefficient R, a range between -1 and +1. If you get the R as 1.3, 1.2, you just make sure that just know what you made a mistake. Maybe when you've been substituting the values on a calculator, you made a mistake. R a range between -1 and +1. And if you get R as L greater than 0, you are dealing with a positive linear relationship. If R is negative, you are dealing with a negative linear relationship. One. Then if R, you get the correlation coefficient L 1, exactly 1, just know that you are dealing with a perfect positive linear relationship between X and Y. Then if R is equal to -1, then you are dealing with a perfect negative linear relationship. You get R as 0, then no linear relationship. So I hope you all understand the properties of the correlation coefficient. So yeah, any questions? Okay. All right, let me show you on how to calculate the R, the correlation coefficient. Let's look at this. Okay. So I'm supposed for other students. Just do this. Okay, it's fine. Just when I raise this with you. Okay. Right. But if in this one. Yeah, I want us to look at the table to calculate the value of R. Because I saw on for Interpolation 2023, 2024, and 2025, they will always, you will not given the summations, but I will check on Sttn 122 module because Sttn 1 and Sttn 122 is the same thing. So I think that remember there was this other question where they were given the summations, not the table. So let's look at this question and analyze them. They say an estate agent is trying to predict the selling price of a house based on its floor area. Okay, based on its floor area. Based on its floor area. So now is the thing. So now so now they say that the estate agent now believes that there is a linear relationship between floor area and the selling price. So you can tell me what is the value of X and the value of Y?
Flow area is X and selling price is Y.
Yeah.
Okay, right. Selling price is Y. And remember we said the X is the independent and the Y is the dependent. Let's look at the first. So in the context, okay, of this scenario, which one is the dependent variable and which one is the independent? Just free 2 marks. Now remember, already we know that the X is the independent and the Y is the dependent. So we're just going to check the options. Flow area is the dependent. This one is out. Selling price is the dependent and the flow area is independent. This is correct because the selling price is Y. And remember why we are dealing with the dependent variable. Then the X, we are dealing with the independent variable. Then you just get your free 2 marks. Yeah, so I hope you all understand. Now they want us to calculate and interpret the value of R. So now we know that this is X, this is Y. So okay, let's do it. On your calculator, make sure that your calculator is on. On your calculator, go to mode setup. Go to mode setup on your calculator. After mode setup, go to stat. You'll see the option of stat on option 2. You will see the option of stat on option 2. Then after that option, you'll see many options, but go to A plus BX. There's option there, A plus B. Can you all see that A plus BX?
A plus
BX.
BX. Oh, number 2.
The question is, why are we using A plus BX? Because that A plus BX, it's a regression. And this chapter is based on the regression. The regression. So when you click that A plus BX, I think on your side, you should be able to see something like X and the Y. A table, like something like a table. So we are going to substitute your values to X, starting from 92.9 till 185.81. You're going to press 92.9 equal sign so that you move to the next step till you reach this. When you are done, go to the Y here, the Y. When you go to the Y, make sure the first one is 200,000. It corresponds with 92.9 till you get to 450,000. Then after entering your values on the calculator, please let me know so that I can give you the next step. Yeah, please let me know when you are done entering your values in the calculator.
Done.
Okay, then press AC on your calculator.
Wait, sir, can you please wait a little? You can proceed, sir.
All right. Yeah, please press AC. And on your calculator, after pressing AC, you will see 0. Okay? And then after, press Shift and Option 1. Like that method, the one that you know on how to calculate standard deviation and mean. But now, when you press Shift and 1, now you will see 5 options. Check on option 5, REG. You will see REG on option 5. Then go to that option. That REG stands for regression. When you go to that option, you will see there's R under that option. Yeah, REG. There's R. The R stands for correlation coefficient. So can I get the value of R?
It's 0.9973.
0.9973, which is
Yes.
this one. So since it's 0.9973, it means that there is a strong positive linear relationship between X and Y, where X, the flow area, and the Y is the selling price. And you also get free 2 marks. That's how you interpret. Any questions before we move to the next part, the section? So I hope now you all know how to interpret the contingency table. You also know how to calculate the relative frequency. You also know how to interpret the scatter plot. You know how to calculate the correlation coefficient. You know how to measure or to interpret the relationship between the X and Y, looking at the value of R or looking at the scatter plot. So I hope you all know how to do that. All right. Okay. So if you don't know how to calculate the value of R on the calculator, please let me know so I can explain the method again. So now I want us to look at because now we are on the R. I want us to look at the coefficient of determination. I want us to look at this one, the coefficient of determination, because now for you to get the coefficient of determination, you need this R. So the coefficient of determination is capital letter R squared, which is equal to, you just open the bracket, that value of 0.997, you put it there, 9973. then you close the bracket to the power 2. The answer that you're going to get here will be the coefficient of determination, meaning every time they say calculate the coefficient of determination, think about getting R first, the correlation coefficient. Once you get the correlation coefficient, it's going to be easy for you to get the coefficient of determination. It's going to be easy. Now, okay, please punch this on a calculator and can I get the answer? There's something that I want to show you, guys.
It's 0.9946.
Okay, 0.9946.
9946.
46. Okay. 46. Okay. So now, I'm not sure if it may be in the exam or on the in the class test that you guys are going to write. You know, I guess they know that you guys know how to find the correlation coefficient. You also know how to find the coefficient of determination using that coefficient of correlation. You know what they will do? You will be given, I get the main, like the uses stats, you know, like the main like ways like to trigger students, but you have to think out of the box. So let's say now you are given the coefficient of determination as 0.9946, and they want you to calculate and interpret the value of the Pearson correlation coefficient between those two variables, x and y. The x as the flow area and the y as the selling price. Remember, you're not given. You see, if I was the examiner or the lecturer, I was going to give you guys the coefficient of determination. I was not going to give you the table. I was not going to give you in the summations. I was just only going to give you the coefficient of determination only as 0.9946. And then I tell you that you must calculate and interpret the value of the Pearson correlation coefficient between the x and y. Or what? Look, check. Now look at this. This 0.9946, it's here. And someone will be happy. I got it. It's here. 0.9. Obviously, they need to choose option 1. It's wrong. But how do you move from the correlation, from the coefficient of determination to the correlation coefficient? How do you move? You just do this. You just say, therefore, R is equal to the square root of R squared. So therefore, R is equal to 0.994. Okay, let me just do this 4 and then 6 like this. You do a square root. The minute you do a square root, now you are getting the correlation coefficient. Yeah, please punch this on calculator and check the answer.
It's 0.9973. Okay, rounded off.
Correct. So that's how you move from the coefficient of determination to the correlation coefficient. If it happens that they give you only the coefficient of determination file, and then they want you to interpret using the correlation coefficient, use this method of this one here. This one, use this one. So yeah. Any questions before we move to the least square equation? Okay. Let's now move to the regression linear relationship. So with regression linear relationship, we use this formula. If they say calculate the least square regression equation, they're talking about y hat is equal to a plus bx. Now, remember, we know, maybe some of you guys, you know this formula, or all of you know this formula. But the question is, do you know what A stands for? Do you know what B stands for? Because they can also ask you to interpret this A or to interpret this B. The value of A stands for the y-intercept. So please note it down on your notes. The value of A stands for the y-intercept. The value of B stands for the slope. So when they're talking about the slope, they're talking about B. And how do you get this whole thing, A and B? On the same data, the one on where you go to option 5 on regression, you saw, I think before Lubona, the R, you saw that there was A option, there was B option. So that A is this one, and the B is this one. So let's go to this and get the equation. So can I get the value of A using the same information? We just say shift option 1. You go to regression on option 5. You will see the value of A there.
So it's negative 68 197.97.
Okay, 68 point or 68,197.97. This one here, the value of A. Because I remember the formula, it says that y hat is equal to A plus bx, like this, A plus bx. Already we got the value of A as 68,197.97. Then what about the value of B?
2785.69.
Then you round it to two, then which will be 70, which is this one. So already you can see you got the value of A, you also get the value of B, which is equal to this here. So already you can see that the answer will be option B. Always when you start with the value of A followed by the value of B according to the equation, then you get your free 2 marks. Now, well, already now when you count is 2, 4, 6, 8, 10, 12. Free 12 marks. Free 12 marks. And you're still going to get the other two, the two, maybe 15, 18, so on. So when I'm saying that it's easy, the regression is easy. So the simple regression is easy. You just need to know how to interpret this whole thing and know the formulas. So this one. All right. Okay. Now let's do question 7. The reason why I want us to do question 7 is because remember I said that the value of A, we are talking about the y-intercept. Please note it down. The value of B, we are talking about the slope. So now they want us to do what? To interpret the slope. And how to interpret the slope? Check. Y hat is equal to 29.38 plus, this is very important. You see this positive sign is very important, plus 2,152.58. So the value of the slope is equal to this number, 2,152.58. The slope, remember, we're talking about B. The slope, talking about the value of B. So it means, go interpreter, make sure, or on that option that you're going to choose, there is an increase. There's an increase on average by that 2,152.58. The reason why I'm saying that there is an increase on average is because it's positive. If it was negative, then we will say that there is an maybe decrease, or they will decrease on average by that number. But because the fact that this is positive, the number is positive, then it means that there will be an increase on average by that number, 2,152. Let's look at the first one here. For a unit increase in the floor area as the X of a house, the selling price of the house will increase on average by 2,152. You saw this one, okay? Then option 2, for a unit increase in the floor area of a house, the selling price, okay, let me admit, okay, the selling price will decrease. One of the minutes you see a decrease, this is out, because this is positive, the number is positive. So when the number is positive, there will be an increase, or one, and one of they said that there will be a decrease. Okay, let's look at this one. A house with a floor area of 0 will, on average, will have a, you can even see that this one is out, because we don't, this with this C, that's not how you interpret the slope. So a house with a floor area of 0 will, on average, the floor area, even this one is out. Now you're left with A and D. No, A and E. For a unit increase in the floor area of a house, the selling price of the house will increase. Okay, we see the increase, but will increase with which average or which slope? 29.38. So that 29.3, is that 29.38 a slope? No, that's the y-intercept, not the slope. So therefore, this is also out. Therefore, the correct answer will be the value of A. Will be the A there. Then you get another 2 marks. But when it comes to this kind of questions, you must make sure that you interpret them like this. You check this one, you interpret them like this, then that's how you end up getting the correct answer. So yeah. So any questions? All right. Okay. Let's go back to this. So already we talked about the formula. This formula. and we set the value of A, we are talking about the y-intercept. The value of B, we are talking about the slope or the gradient or the average. So this is how you interpret one. Okay, for each unit x increases, the value of y will have average, it will increase by this number. So yeah, I lost the thing. Then we also talk about the residual. Now, the residual is the simplest. Okay, let's look at this. So I want you guys to write down this formula. That formula is for residual. So the residual, I'm just going to put R. R is equal to the y minus the y hat. This is the formula for residuals. So got this one. Let's say you are given the intercept. You're given the intercept as 10 and 40. Now 10 and 40. They say we must use this equation 29.3 2152. So now the y hat is equal to 29.38 and then plus 2152.58. I think it was 58x. And then they say calculate the residual. Remember the residual formula, it says y minus y hat. What is this y hat? Is this one here. And the intercept, it's 10 and 40. 10 ke x, y ke 40. I think you'll remember this from grade 12. With grade 12, when you were or draw a graph, either what is the thing? A straight line graph, or when you draw hyperbola graph. Like when you draw the graph, you're dealing with the intercept. Okay. Now, if this is the intercept, the 10 will be x, the y will be 40. I hope you know what I'm talking about. 10 is x, y is 40. So if it's like this, for you to get this y hat, it means where you see x, you are going to put 10. You're going to put 10. You're just going to do this. No, I don't want this one. I want this one. So where you see x, you're going to put 10 like this. Then you get the y hat. You get your y hat. You substitute this on a calculator, you get your y hat. The y will be 40. So to get the residual, just going to say the r is equal to the y 40 minus this answer, the one that you've got here, your y hat. Then you get your residuals, then you are done. I want to ease.
Yeah, it's easy. So can you please explain it again, please?
All right, okay, I'll explain it again.
Yeah.
Okay, I'm saying with the residuals, you use this formula. Y minus y hat, where the y hat is the equation of the least square. So I was saying that if, let's say, for example, you are given the intercept as 10 and 40, like this, as 10 and 40, the x will be 10, the y will be 40. I do know that if they give you intercept, coordinate graph, but 2 and 4, you know that the 2 is x and the 4 is y. You all know this name, this one. But this is x, this is y. So now for you to get the residual, step 1, calculate the y hat bill. Oh yes, when you calculate the y hat bill, where you see x on the equation that you'll be given, you're going to put that 10 because x, you just put this 10 here where you see x. We are going to get the y hat when we substitute this on a calculator. After getting the y hat, now you're going to check the y. Remember this one, the one with the outlook at the y hat, it's 40, and it's this one here, this one. You're going to say 40 minus the answer that you've got here, y hat. Then by saying that 40 minus this, you get your residual. One. Yes.
So we'll always be given the intercept, will not be asked to calculate it.
I think you will be given our intercept. Let me show you something. I think it was, I don't know if it was which question paper where you were given No, not this one. This is, I think this is 2024 question paper. When they say you must interpret the value of the slope, and you know that the value of slope is this one. Now it's minus, and obviously you're going to have a decrease. But let me show you the one. Yeah, well, look at this one. No one. No, I don't want this one. This one is not about the thing, the residual. But with this one, this is easy because where you see x, you just put 65, then you just get your answer. This one is not a problem. I need the one, even with the question of determination. Remember, I said you need what? You need R. You need the correlation coefficient to get this. And when you check, you are given the table X and the Y. So there's this question they gave out loud, the one with the residual, so that I can show you the questions that are based on the residual. Yeah, look at this. Or what? Look at this. I think it's the same thing, the other thing that I was explaining. Suppose the equation of the estimated least square regression line is given by, this is our equation. They say the second paired observation, even if they are just trying to show that the first one is X, the second one is Y. Y1 in the data set is 28 and 510. So meaning 28 will be X and 510 will be Y. And remember, to get the residual, calculate the residuals, you're going to say the residual is equal to the Y minus the Y hat. And what is the Y? It's 510. So you're just going to say 510 minus, what is the Y hat? Where you see X here, you're going to put 28 like this. And then you get that answer that you're going to get here, that will be your Y hat. You're gonna subtract it here. Then you get your residual. Then you get your free 2 marks. So yeah. Okay, let's see. We talked about the residual. And what's the other thing? And then another thing with this one also, this one, just take it as the 1 year R. Or if they don't give you a table, they will give you summations. And when they give you summations, you use these formulas to get the value of A and B. What means it's when you get the equation. So got this one. Don't worry about this one because you will be given summations for one. So it's going to be easy for you to get the value of B and A. But if they give you a table, you know how to get the A, you know how to get the B or one. You know how to get the value of A and B. What is the other thing I want us to talk about? Yeah. I think the last thing that I want to talk about is the interpolation and extrapolation. With this one, please pay attention. Ne? It's easy. Very, very easy. When you think about the interpolation, extrapolation, even this one is going to be there in the test. I think so. That in the test, it's going to be there. And also in the exam, the interpolation and extrapolation. So how do you interpret this whole thing? Yeah, interpolation and extrapolation. Let me show you this. Let me just do this. Okay, let's look at this. So the interpolation, it's when you estimate a Y value, meaning it's when you estimate that Y value. I'm going to show you an example on how to interpret this whole thing. It's when you estimate a Y value for a given X value, meaning when you are dealing with the interpolation and extrapolation, you will be given the X value. Ne? Once you're given the X value, you're going to take that X value, you substitute that value, or the equation, yeah, the least square. You get the Y hat. That Y hat, it's when you estimate a Y value. Now, after getting the Y hat, remember, you'll be given the X value. Ne? You'll also be given the equation. You just take the X value, you substitute that X value, go to my equation. Which are the answer that will be the Y hat. That Y hat, that part where you estimate a Y value. Now, immediately you get that answer. You will back to your table. There on the table that you will be given, you're going to check under the X table. Okay, I'll show you now. I will show you what I'm talking about. You're going to check under that X table. You're going to check if that number, is it inside or outside? How do you check? Let's look at this example so that you can check. This is inter. Inter, it's inside. Extra, outside. When you think about inter, inside, extra, outside. The keywords inter, inside, extra, outside. Let's check. Okay, this is our table, ne? This is our this is our table here. So you will be given this sorry, you will be given this equation 1.394 plus 1.328x. Now this say which suppose the airline must spend 10,400 on advertising. They want to know how many passengers do we expect will make it. But Bona, with this kind of questions, they're going to ask whether is it an interpolation or extrapolation. So now, with those kind of questions, how do you get to a point where you're going to say this is interpolation, this is extrapolation? How do you get to that point where you say that? Now you're going to subtract but it's 10,400, so it's measured in terms of thousand. You can just say 10.4. That's why here they say that it's 10.4. But go test or exam, it's about more specific. So a more specific. Now you're going to use your equation like this, where you see x here, you put 10.4. The answer we got 15.21 again. So after getting 15.2, remember I said, go to your table. When you go to your table, check under the x. Check if there is 15.21. Not, you don't have to necessarily get 15, exactly 15. You just need to check if it's there under those intervals. So when you check, can you see that we do have 15.21 under these intervals here? Meaning, what I'm trying to say that 15.21, it's inside these intervals. Can you all see that?
Yes.
Yes. So since 15.21, it's inside the interval, we say this is interpolation because it's inside the intervals. Now, another example, we're given the same equation, but with different scenario. So here, we're given the x as 20.1 because it's measured in terms of thousand. Then we substitute here, they got 28.09. We need to check whether it's interpolation or extrapolation. Remember, after getting this answer, go and check on the table. We're going to check if we do have 28.09 here. Can you see that we don't have that value? Even we don't have 20 something, 20, we don't have 21, we don't have 22. So it means A outside. A outside. So really outside, we say this is extrapolation. Then here it is extrapolation. So yeah. So that's how we interpret the questions that are based on interpolation and extrapolation. Let's check if we do have that interpolation and extrapolation. Where is it? They just give you the same thing. I want to interpret this. You're given X, you're given Y, they want the residual. Same formula. The one that I showed you. You know how to work with the coefficient of determination. Even this one, what does the coefficient of determination R squared in simple linear represent? So let me not say boring. When you look at this one, I agree R, the correlation coefficient, it represents the strength of the relationship between the dependent or the independent variable. But now, got the one of R squared. This one, it's how well the estimated regression line if it the observed data. Get this one. Let me show you. Get this one. This one, the coefficient of determination, it provides an indication of how well does the least square fit the observed data. The difference score, the correlation coefficient here R, it measures the relationship between X and Y, between independent variable and the dependent X and Y. Now, got the coefficient of determination, it provides an indication of how well does the least square curve fit the observed data. Get this one. How well the estimated regression line fits the observed data. Got this one. Then you get another free 2 marks. You also get free 2 marks here, free 2 marks here. So, but I wanted the one here. This one is chapter 7, time series. I wanted the one year interpolation and extrapolation. So I think it's this one, if not mistaken. The one with interpolation and extrapolation. Okay. A prediction will be an extrapolation when. Okay. A prediction will be an extrapolation when. So this here, You don't have to put where you see X, you have to put the thing. You just need to check here on this whole thing. You just need to check. And remember, you're going to check the table, whether that number is there. Is it there? Let's check. Obviously, we'll be looking under X, the age, not the distance. So when you check under X, they mention distance. We don't want this one. The age. So at the age predicted for distance, you have 40. We're going to check if that 40 is it inside or outside. Let's go and check if we have 40 there. So let's check. Yes, 40 is there. So it's inside. So that's interpolation. And whenever extrapolation, this is out. We need the number or outside. Okay, and age is predicted 95. We're going to check if 95 is inside or outside. Let's go and check. Where's 95? Do we have 95 here? No, we don't. It's outside. So the answer will be option C. This one. We get another free 2 marks. So that's why I'm saying that is easy. That's an interesting module. So, and remember, it was from 1 to 2:30, ne? From 1 to 2:30, and we said we will do chapter 5. So this is what I'm going to do now. Please remind me tomorrow. I guess tomorrow we are going to have a session at 6 o'clock. I think I sent an announcement in the group. I will also send the one announcement on Ifundi tomorrow in the afternoon that we're going to have a session in around 6 o'clock in the evening. I'm gonna also put the MS Team link on Ifundi and also in the group. So we're going to start with a chapter 5 revision, because now we're focusing on chapter 6. Then tomorrow, during that session, the online session, we're going to start with chapter 5 revision. Then after, we do the questions. So I'll try to, when I come back from campus tomorrow, I will try to compile a test 3, the questions that are based on test 3, chapter 5 and 6, put them in one document and send the document in the group. So I hope you enjoyed today's session when we've been discussing chapter 6. So let me know if there's any questions, because our time is up now. But tomorrow we'll discuss chapter 5. Okay, let me do this. So yeah, any questions?